Hello, welcome to lesson 5.5, measurement with polygons. It is our expectation that you have memorized any formula that has a star next to it in this area. We will give you the formulas that don't have stars next to them, but in general, you need to know these formulas, and the faster you know them, the less time it's going to take you to do these problems. So, real quick, a lot of this is review, I think all of this is review actually, but a parallelogram basically is just base times height, where the base is always perpendicular to the height, and our subcategories of parallelograms all follow that pattern. Rectangle, we've always said is length times width. Well, guys, that's just base and height, so it's basically the same thing. Rhombus is base times height, or we have this weird equation that y'all have seen once before, 1/2 diagonal 1 times diagonal 2 over times 1/2 times the product of the diagonals. A square is just side squared. Again, that's a base times height, right? Just happens that your bases and your heights are the same. A trapezoid is the average of the bases times the height, which is 1/2 b1 plus b2 times the height. So here you can see we've got 6 and 14 as my bases, so I do 1/2 6 plus 14 times height of 6. So not too bad. And a kite is the same formula as a rhombus, 1/2 times diagonal 1 times diagonal 2. We can find perimeter of figures simply by finding the length of each side and adding them together. Here we have a truly, truly ugly example where I give you coordinates and you're supposed to go through and find the perimeter. Well, to find the perimeter, that means I have to find the length of each side. So I do that. I use my distance formula to go through and find the length of each side by plugging in my coordinates. I set A as -4, 6, B as 2, 2, and C as -2, -2. I plugged in and I got all of their lengths of their sides. Notice none of them are nice, right? Those are all hideous and ugly numbers, plugging into distance formula. And my perimeter then is just the sum of all of those ugly numbers added together, basically. So take a moment, pause the video, look through this, check my work because it might be wrong, you never know, and go on to the next page. We sometimes have much easier examples for perimeter. For example, here's a very irregular shape. When I look at this shape, I can see that I've got 3 sides of a rectangle and I've got half a circle. Well, the side of this rectangle here is really the same as 2 radii of this circle. So if the radius is 4, then this side must be 8. So to find my perimeter, I do 3 sides of my rectangle plus half the circumference, and my 3 sides are 8, 12, and 12. And my formula for circumference is 2 pi r. Well, I'm taking half of that, so a half times 2 pi r. I keep plugging in and simplifying until I get an answer of 32 plus 4 pi. And yes, you can leave your answers in terms of pi. That's great. That is called the exact answer. Even though it looks ugly, it's the exact answer. If I were to change this into a decimal, it would be an approximation at that point. So, then we're going to talk about surface area. Surface area is simply the sum of the areas of each surface of a figure. When you forget a formula for surface area, what you really need to do, when in doubt, is just find the area of each side and add them together. If you forget your formulas, you can get there. It just might take you longer. Knowing the formulas is a shortcut. It's not a necessity. Prisms and cylinders basically have the same formula for surface area because both rely on the concept of unwrapping the figure to produce the surfaces you're going to calculate. Their surface area always includes 2 parts, the area of the bases and the lateral area. The lateral area is the area that would be like the label on a soup can. That's my lateral area. So the formula for surface area is 2 times the base area plus the lateral area. Whenever I use a capital letter in geometry, that means I need to do more work to find that value. So capital B means I need to do work to find the area of the base, and capital LA means I have to do more work to find the lateral area. Well, lateral area is always going to be the perimeter or circumference times the height or altitude. So LA equals P times H, and so my surface area is just 2B plus PH. So, or again, when in doubt, just make a list of all the surfaces and add their areas together. So if you forget that formula, it's okay. You can still find surface area. It just is going to take you more time. So here we have a regular hexagonal prism, and I start with my surface area, which is 2B plus LA. Well, what I need to find first is the area of the base. The area of the base, it's a regular hexagon, so I'm going to use my formula for a regular polygon, which is 1/2 perimeter times apothem. Well, in order to do that, I need the perimeter, and perimeter is just the side length times the number of regular sides. And that's perimeter of the base, by the way, perimeter of the base. So 10.6 times 6 gets me a perimeter of 63. I then can go and plug that in to my base area formula, 1/2 perimeter times the apothem, and my apothem is 9.2. So my base ends up being 292.56. I then need to find the lateral area. Lateral area is just perimeter times height. Well, we already found the perimeter, and they give me a height of 33, so I get my lateral area. So then my surface area is 2 bases plus the lateral area. I simply plug in and solve. Easy peasy. So we're then going to repeat the whole process now for the cylinder over here. My cylinder, I'm using the same formula. Surface area is 2 times the area of the base plus the lateral area. My base this time, though, is a circle, so I use my formula for a circle, pi r squared. So here, r is 1. My radius is 1, so I plug in once. My base just ends up being pi. It's really nice and easy. Lateral area is always equal to perimeter times height. Well, the perimeter in this case, because we're dealing with a circle for a base, is the circumference, and my formula for circumference is 2 pi r. I plug in for r and get that my circumference is 2 pi. So going back to lateral area equaled perimeter times height. Well, here I plug in for perimeter is 2 pi, multiplied by the height, which is 6, and I get 12 pi for my lateral area. Then we could finish off one more time. Surface area is 2 bases plus the lateral area. Well, my base area was pi, my lateral area was 12 pi, so I got 2 times pi plus 12 pi, which gets me 14 pi meters squared. We can also find the surface area of pyramids and cones. Pyramids and cones are really, really similar. We're also going to think about unwrapping the surfaces when we do this. But here, as you can see, we only have 1 base this time as opposed to 2. So my surface area formula ends up just being base plus lateral area. And the lateral area this time, because my lateral surfaces are all triangles on the pyramid and vaguely triangular curvy shaped on the cone, it ends up being 1/2 perimeter times slant height. And cursive L is slant height. My slant height is going to be this distance right here when I'm going up the side of the pyramid. My slant height here on the cone is just the distance as I follow along this edge here on my cone. This is different to height. Remember, height is always perpendicular to a base. Slant height is not perpendicular to the base. It is a slanted height. So, formula again for lateral area was 1/2 perimeter times slant height. So let's take a look at some examples. First one here, we've got a cone. So I start off with my surface area. Surface area equals base plus lateral area. I fill in my base this time shaped like a circle, so that'd be my base formula would be pi r squared. R is 5, so I plug in to get 25 pi for the base. Lateral area is 1/2 perimeter of my base times my slant height. Well, perimeter this time is actually the circumference of the base, which is 2 pi r. Plug in 5 for radius, and I get that my circumference is 10 pi. So going back into my lateral area formula, I have 1/2 times the perimeter of the base, which is 10 pi, times the slant height, which in this case is 13. So I end up getting 65 pi for the lateral area. Surface area is simply the sum of the base and lateral area. I plug in 25 pi and 65 pi to get 90 pi units squared. So we then have something similar going over here with this pyramid. I will say right now we have something slightly mislabeled. This 17 shouldn't be labeling this edge. It should be labeling, ooh, that is really not what I wanted to draw there. Undo. It should be labeling this right here, the slant height that goes from the point to the midpoint of the opposite side. That's what the 17 is supposed to be labeling. So here, my base is shaped like a regular pentagon, so I use my formula for area of a regular polygon, which is 1/2 perimeter times apothem. Perimeter, of course, is the number of sides times the length of the side, which gets me 58. Plug in to get a base area of 232. My lateral area is 1/2 perimeter of the base times the slant height. Well, good news, guys, we just calculated perimeter a minute ago when we were doing base area, and we got 58 for the perimeter, so I can plug straight in. 1/2 times perimeter times slant height gets me 493. So my surface area is simply the sum of those two things added together, my base area and my lateral area. I add them together to get 725 feet squared. And last but not least, we have volume. The volume of a prism or cylinder can always be found using this really easy formula: volume equals area of the base times height. Remember that height has to be perpendicular to the base. If our solid is a cylinder, where B equals the area of the base, or in this case that would be a circle, we can reduce this formula to volume equals pi r squared times h. Honestly though, I'm going to always use capital BH and just work from there. So here, I give you a cylinder. I know volume equals area of the base times the height. Well, the base in this case is a circle, so I can plug in pi r squared for my capital B and multiply that by the height. Well, in this case, r is 1, h is 6, so I end up getting volume equals 6 pi meters cubed. On the other diagram, we have a triangular prism where volume equals base times height. Well, the base itself is a triangle, which is the area of a triangle is 1/2 base height. Notice, this is a different height than the height here. This height in the area of the base formula needs to be the height of the triangular base, not the height of the prism. And this lowercase b is the base of the triangular prism. So when I plug in, I do 1/2. My base here is 11.1 because it would be the same as right here. And my height of the triangle is 6.2. Plug it into a calculator, I get 34.41. So volume equals area of the base, 34.41, times the height of the prism, which again, the height of the prism is this right here. It's perpendicular to the base of the prism, so it's 14.7, and I end up getting 505.83 millimeters cubed. Volume in cones and prisms is remarkably similar, except rather than dealing with just B and H, we have to divide it by 3 because it comes to a point. So that's what we're going to do. Right here we have a pentagonal pyramid. So I plug in volume equals 1/3 base times height. Well, my base formula is 1/2 PA because it's a regular pentagon. Plug in the things I know. I get that the perimeter is 58, so my base is 232. Plug in for capital B into the volume formula, and my H, which of course is perpendicular to the base, so that 15, 1/3 times 232 times 15 to get me a volume of 1,160. Now, over here on my cone, I'm missing a piece. Sometimes you're going to have to use Pythagorean theorem to find the thing that you need. I'm missing the height, so I had to use Pythagorean theorem by doing 5 squared equals h squared plus 13 squared to solve for my missing h right here. Okay. We ended up getting that h is 12. I plug in. My base in this case is a circle, so we do pi r squared for the base area. Base equals pi r is 5 squared, gives me 25 pi. So I come back to my volume formula. Volume equals 1/3 area of the base times the height. Plug in, I get 100 pi units. All right, guys, thank you all so much. I'll see you in class and bring any questions you have. Thank you.